of vibration in an introduction class itself. In the introduction class itself, we've seen that three types of vibrations. Okay, longitudinal vibration, transverse vibration, and torsional vibration. Okay, in a longitudinal vibration, the vibration will be acting then along the axis is called a longitudinal vibration. Okay. And next one is called transverse vibration. It's called against the axis of an component, okay, or things or something like that. That is called an transverse vibration. Torsional vibration is called an rotation. Okay, rotation. I already explained about this through one diagram also. Okay, just we are going to see about the torsional vibration introduction and based on the problems based on that. Okay. Yeah, this is called a torsional vibration. You can see two pictures here. One is called the orange color will be there. Okay, this one is called twisting moment. Okay, look at the axis will be turning here and there. Okay, clockwise as well as anti-clockwise direction. Okay, this is a diagram is called shown in a GIF file. This is called an ANSYS output. Okay, torsional vibration ANSYS output in normal. While it will be rotating, what will be happens in the material that will be shows in this diagram. Okay, yeah, and this is called an introduction. In this, when the shaft is twisted and untwisted alternately, the torsional shear are induced. Okay, this twisting and untwisting movements is known as torsional vibration. Just introduction and a general introduction about the torsional vibration. Okay, when the shaft is twisted and untwisted alternatively, then torsional shear stress are induced. Okay, that this twisting and untwisting movements are known as torsional vibrations. Okay, the particles of the body move in a circle about the axis of the shaft. Okay, and this is also another definition about that torsional vibration. Okay, yeah, and this is a small derivation about the torsional vibration. So natural frequency. I already given the definition about that natural frequency and forced frequency, all these things. Okay, and this is the same diagram what you seen in the last thing. That's the same thing. It will be here. Okay, this is called a mean position. This is called an up to it will be moves. That is called a theta, and this is a maximum position, minimum position to maximum position. Okay, this is a twisting, and this is taken as a time. Okay, so for this we are going to derive the one equation that is called torsional one. Okay, theta is called angular displacement of the shaft, and m equal to mass of the disc. Okay, in some cases the mass of the shaft is also taken into consideration. Okay, so in general we take it as an mass of the disc only, it will be taken into account here. Okay, we know that I equal to mass moment of inertia. Already we solved in the first unit that I equal to mk square. Okay, mass moment of inertia, that is called mk square. Okay, k equal to radius of gyration in terms of meters, and q equal to torsional stiffness. And this torsional stiffness and q values we already seen these things in an engineering mechanics itself and as well as in the strength of materials. Okay, in both things we already seen these things. Okay, these are the terms it will be used in the torsional vibration. Theta, mass, I, and the k radius of gyration, and the q equal to torsional stiffness of the shaft. Yeah, and there is a definition about derivation about that. Restoring force q into theta, the oscillating force I into d square theta and dt square. Equation both are equating both equation number 1 and equation number 2, equating these two equations. Okay, we get that d square theta by dt square plus q by I into theta, okay, equal to 0. And fourth one, the fundamental equation of simple harmonic motion. Because of a simple harmonic motion, it's an oscillating, we take it as a simple harmonic motion there. Okay, so that thing d square theta by dt square plus omega square into x equal to theta. Okay, this is equation number 3 and equation number 4. Comparing of these two equations, okay, we get that omega equal to square root of q by I. Omega equal to square root of q by I. That's a formula for this torsional equation. Okay, and one more formula on time period. This time period equal to 2 pi y omega. With these things we already seen in the free vibration itself. The same formula only. There's no need of any worry about that. Okay. All the time period natural frequency is having the same formulas. Okay. A natural frequency Fn equal to 1 by Tp, and that is equal to 1 by 2 pi square root of Q by I. Okay, this box formula it will be same as like an what we see in already in free vibrations. Okay, and this is a formula it's only different here. Omega equal to square root of Q by I. Okay, and next one, yeah, this equation is called torsional equation. We call it as none. We seen in the distance in the strength of materials. Okay, T by J C theta by L. T equal to twisting moment, J equal to polar modulus, C equal to modulus of rigidity, and theta is a twisting moment, L equal to length of the shaft. Okay, the same thing it will be rewritten like this here, T by theta into Cj by L. Okay, instead of an Cj by L, we can write as a Q also, because T by theta equal to Q here. Okay, that will be mentioned here. Okay, given in the note. T by theta is nothing but of Q. This Q equal to, then formula it will be rewritten as a Q equal to C into J by L. J equal to polar moment of inertia. Okay, pi by 32 and d power 4. The same formula it will be used for your auto shaft also, but the formula is will be differ. Okay, J will be same. The formula will be differ. J by J equal to pi by 32 d1 to the power of 4 minus d2 to the power of 4. Okay, that is called d1 and d2 is called an inner and outer radius. Okay, make a note of these formulas. Okay, once again and put this slide, previous slide, omega equal to Q by I. Make a note of these formulas. I move on to the next slide now. And this formula, and this is also important formula. In all this torsion vibration, we are going to see these formulas only. Yeah, a simple problem based on the torsion vibration. Yeah, a shaft of 100 mm diameter and 1 meter long, as one of its end fixed and another end carries a disc of mass 500 kg at a radius of gyration of 450 mm. The modulus of rigidity of the shaft material is 80 giganewton per meter square. Determine the frequency of torsional vibration. Okay. There's no need of a diagram, but we already seen in the introduction there's one diagram. This same diagram it will be used also there. Okay, because the one end is fixed there, another end is carrying the disk of mass some value. Okay, you can use this diagram that there also. Okay, for that problem, take this diagram in your mind, and this same it will be represent there. Okay, make a note of this diagram. Okay, given data will be given, converted into meters. D equal to 100 mm, that is 0.1 meters, and L equal to 1 meter, mass equal to 500 kg, and K equal to 450 mm, that is 0.45 meters. C is equal to 80 giganewton, that is 80 into 10 power 9 Newton per meter square. Okay, and this is a solving method. Okay. J equal to pi by 32 d power 4, that is called J equal to pi by 32 d power 4, polar moment of inertia calculations, the first thing. And second one is called torsional stiffness of the shaft. Q equal to C into J by L. Q equal to C into J divided by L. Okay. That is C equal to 80 into 10 power 9, and J equal to, just we find out that value, that is all 9.82 into 10 power minus 6. Okay, and divided by L equal to 1 meter. Okay, Q equal to Cj by L. To this formula, we can get the value of 785.6 into 10 power 3 Newton meter. That is at Q, torsional stiffness of the shaft. Okay, and then I equal to mass momentum of inertia of the shaft. Okay, M equal to 500 kg is given. And the radius of gyration is also given as 450, that is 0.45 meters. that is 0.45 square. Put together the value is 101.25 kg meter square. Okay. Uh, Next one is called frequency of torsional vibration. Okay, this is a formula. F1 equal to 1 by 2 pi square root of Q by I. 1 by 2 pi square root of Q by I. Just we find out the Q value here. That is 785.6 into 10 power 3. Put it here. And I equal to mk square. That is 101.25 kg meter square. Okay, put both the values here. We get the value as 14 Hertz. 14 Hertz. Okay, frequency of torsional vibration is 14 Hertz. Okay, just go through the question once again. I put the from problem page. Move on to the next sum. This is a simple problem. This kind of problems will be asked for some gap. Okay, some questions will be asked for 8 marks or 9 marks means it will be used for 5 or 4 marks. This kind of questions. Okay. Yeah. Take down the next sum. A flywheel is mounted on a vertical shaft, as shown in the figure. Both ends of the shaft are fixed and its diameter is 50 mm. The flywheel has a mass of 500 kg and its radius of gyration is 0.5 meters. Find the natural frequency of torsional vibration if the modulus of rigidity is 80 giganewton. Okay, like that. The same kind of a sum we can solve in a longitudinal vibration also. Okay, here it will be used for a torsional vibration. Okay, only one thing is the frequency formula, it will be changed. Okay, remaining things are same here. These are data. D equal to 50 mm and the mass equal to 500 kg. Mass equal to 500 kg and K equal to 0.5 meters. G equal to 80 giganewton. Okay, that will be converted into 80 into 10 power 9 Newton per meter square. Sorry, man, I think it is a printing mistake here. It will be here. It will be given as 80 giganewton, but here is rewritten wrongly as 84. Okay, make a note of an 80 only. Okay. Yeah. So okay, change in the question itself because in the solving area we have taken as an 84 only here. So you can change in the question itself. Okay, 84 giganewton. Okay, sorry man. And J equal to pi by 32 d power 4 polar moment of inertia. And next one is called torsional stiffness of the shaft for a length L1. Okay, yeah. In this diagram you can see that there is a 2 part. Okay, taken as a 2 part because it will be taken as an L1 and this is taken as an L2. Okay, so you want to find out the Q in 2 times here because this is be taken into 1 part. Okay, from top into middle of this 0.9 meters and the middle of this to end of that. Okay, this will be solved as a Q1 and this will be solved as a Q2 here. Okay, so Q1 into C into J by L1. Okay, L1 equal to 0.9 meters. Okay, C and J will be same for all those things. Next one, Q2 calculation. C into J by L2, 84 into 10 power 9 into 0.6 into 10 power minus 6 divided by L2. Look it out here, L2 will be taken as a 0.6 here. In the diagram, it will be clearly mentioned 0.9 meters and 0.6 meters. Okay, for this kind of thing, the diagram it will be clear, given clearly here. Okay, so C into J divided by L2 here. L2 value is 0.6. So you want to find out, already we find out the Q1 value. Now we find out the Q2 value. So put together, that is called total torsional stiffness of the shaft. Q equal to is nothing but of Q1 plus Q2, that is 56 into 10 power 3 plus 84 into 10 power 3, that is 140 into 10 power 3 Newton meter. Stiffness, torsional stiffness. Okay, this is not a stiffness because stiffness, the unit is Newton per meter. Here is called torsional stiffness. Torsional stiffness, the total thing it will be changes here. Okay, and I equal to mk square. So 500 into zero point 0.5 square, that is 125. So frequency equal to 1 by 2 pi square root of q by I. Okay, q is already find out here, and you can use this method, and you can get the frequency of 5.32 hertz. Okay, 5.32 hertz. In some type of a problem, what they asked, the same question it will be asked in an uh, two frequencies. You want to find out the two frequencies here. First frequency and second frequency, that is called, first you want to find out for the Q1 value, and then again you can go for the Q2 value. Okay, two frequencies. Okay, but the two frequencies are differ. Some conditions it will be same, some conditions it will be vary. Okay, so the frequency of total overall is equal to 5.32 hertz. Okay, just go through the sum for a moment. I kept it from the first slide. And still 5 of them is absent in the class. Friends யாராவது இருந்தீங்கன்னா கொஞ்சம் ரிமைண்ட் பண்ணுங்க. Go through the slides. I move on to the. Shall I move on the next slide? Students, one more thing. Yesterday we posted the assignments for dynamics. No one it turned up. I think very few of them, less than a 10, I think so. Okay. Remaining of them, please post the answers. The solved one, the same model, it will be available in your book itself. Okay. The books are already shared to you through Google Classroom as well as in WhatsApp. Okay. Suresh are also, it will be posted there, some notes for that. Okay. Please go through that and solve the assignments. Okay. After you finish your classes, solve your assignments and repost it.
The last date for
From
submission.
today onwards, you have a performance enhancement classes. Okay. Tomorrow for dynamics.
The last date for submission assignment.
Yeah. Our next topic. Up to this, what we've seen is in a general one. Okay. This is for a single rotor system. Okay. We are here. We can go through for three types of a rotor system.
single rotor system, two rotor system, and three rotor system. In the initial, I saw one GIF file. Okay, for you. Okay, for example, and the same thing, it will be called continuously in a one shaft. Continuously, there is an rotors will be fixed. You can take it as an example, motor and a pump. That is also on rotor system. One end is fixed and another one is rotating. Okay, and this is called a single rotor system. Okay, that is one a good example. And a motor and a pump, you can take it as a two rotor system. One end is fixed. In center, there's a motor will be there, and the end will be a pump will be there. Okay, that is called a two rotor system. Okay.
Wait a moment, students.
Just go through the slides. I'll come back.
Unduma.
Yeah, just go through this one. Our next topic is called based on a single rotor system. Okay, I am audible to you now.
Sir,
It's in a okay, sir. Okay. It is a single rotor system. There's a three kind of things we are going to see in a torsional vibration: single rotor, double rotor, and triple rotor. Single rotor, two rotor, three rotor system. Okay. In a first one single rotor system, the same kind of a formula you can use: F1 equal to 1 by 2 pi square root of Q by I. Okay, that's a formula you can take into account. Okay. The same formulas, the same data. Okay, already we've seen this one. Okay. Here is called an node system. It will be followed. Okay, the node system, we know that once in a cycle, the end of a cycle, we call it as a node. Okay, the one point will be crossing the amplitude of torsional vibration is called node. Okay, it will be given here itself. It may be noted that the point or section of the shaft whose amplitude of torsional vibration is 0 is called as node. In other words, the shaft remains unaffected by the vibration. Okay. Node kind of definition கொடுத்திருக்காங்க. And this point is called node. You want to calculate the node position here. Okay. First thing you want to find out the frequency, and second one you want to find out the node positions. Okay, where it will be lies in this shaft. Okay, that's the thing you want to find out in a torsional vibration. Okay. Yeah, and this is called a two rotor system. Look at it. For this only I given the example. One end is called a motor and another one is called a pump. Okay, this will be taken as a two rotor system. That's a good example for you. Okay, and this is a two rotor system. In this system, a torsional vibration occurs when two rotors A and B in opposite directions. Okay, A moves in anti-clockwise direction and B moves in a clockwise direction for the same instant and vice versa. Okay, and this will be taken as a two rotor system here. And this is called a node diagram, and this node diagram, this is called node position. Okay, and this is length of B and length of A, and a P Q, it will be node positions will be given. Okay, and you want to find out this LA value and this LB value. Okay, LA and LB, and this is called a node diagram for you. பார்த்துக்கோங்க, இதை பேஸ் பண்ணி தான் உங்களுக்கு எல்லா சம்ஸுமே வரப்போகுது இதுக்கப்புறம் டார்ஷனல் வைப்ரேஷனை பொறுத்த வரைக்கும். ஓகே, டயக்ராம் வந்து ரஃபா வரைஞ்சா போதும். there is no need an exact scale diagrams here. Okay, just for your reference, and rough diagram it will be enough. Okay, but there must be a diagram must be present in the each and every sum for you, like this. What will be given here? Okay, this is called an L. Listen, L will be mentioned in the shaft, that is to be application. Okay, diagram la. and LA, LB, L1 minus LB, and L1 minus LA, L2 minus LE, LB, இது எல்லாமே வந்து கீழே நோட்டேஷன் வர்றது எல்லாமே வந்து பாத்தீங்கன்னா நோடுக்கு வருது. புரிஞ்சுக்கோங்க. இங்க பாத்தீங்கன்னா A and B கொடுத்துருக்கு, இந்த லென்த் வந்து L. ஓகே, and some diagrams the position is also changes. ஓகே, so LA LB அப்படின்னு வருது, L2 minus LA, L2 minus LB, L1 minus LA, L1 minus LB, இந்த மாதிரி பொசிஷன், இந்த மாதிரி டேட்டாஸ் வர்றது எல்லாமே வந்து இட்ஸ் கால்ட் அ நோட் டயக்ராம். ஓகே, திஸ் நோட் டயக்ராம். ஓகே, okay, the same thing it will be given what I mentioned earlier. It's called L equal to length of the shaft, L equal to length of part NP, distance from node A. Look it out here, distance of node from rotor A. In the point length, in the point, that is called L ன்னு சொல்லிருக்காங்க. புரியுதா? LB equal to length of the part NQ, distance from node from rotor B லந்து. Okay, IA equal to mass moment of inertia, IB equal to again the mass moment of rotor B, D equal to diameter of the shaft, polar moment of inertia, and C equal to modulus of rigidity. Okay, this is a thing it will be given. And one more thing is called an LA, LB, IA and IB, D. இது எல்லாமே சேம் தான், பட் D மட்டும் சேஞ்ச் ஆகும் in case of hollow shaft. Okay, the some problems the D1 and D2 is given. Okay, because of the inner diameter and outer diameter, D1 and D2 both the things will be given. Based on this the formula will be changes. Okay, D மட்டும் சேஞ்ச் ஆகிறதுக்கு வாய்ப்பு இருக்கு. Okay, this is called frequency of NA. Frequency of NA equal to 1 by 2 pi square root of C into J LA into IA. Listen man, இங்க பைன்றது வரணும், மிஸ் ஆயிருக்கீங்க. Okay, Fn of B equal to 1 by 2 pi C into J LB into IB. Fn of A equal to Fn of B, because frequency acting in a rotor A, it will be equal to frequency of rotor acting in a B. Okay, both the things are same because it both the things acting in a same shaft. Okay, it's not a different shaft there. புரியுதா? உங்களுக்கு டயக்ராம்லயே தெரியும். ஓகே, சோ இங்க என்ன ஃப்ரீக்வன்சியோ அதே ஃப்ரீக்வன்சி தான் இங்கேயும் இருக்கும். புரியுதா? சோ அதுக்கு தான் அது கொடுத்துருக்காங்க. Frequency doesn't changes here. Okay, so for that only it will be given Fn of A is equal to Fn of B, that is 1 by 2 pi square root of Cj by LA into IA, that is equal to 1 by 2 pi C into J LB into IB. So that is nothing but of cross multiply of all these things, we get of LA into IA is equal to LB into IB. புரியுதா? இதுதான் இங்க வந்திருக்கு. LA into IA is equal to LB into IB. Okay, so therefore LA equal to LB into IB divided by IA equal to நீங்க வரணும் LA equal to LB into IB divided by IA. One more thing is called L is nothing but of LA plus LB. L is nothing but of LA plus LB. ஓகேவா? ஸோ புக்கில் கிளியரா இருக்கும் உங்களுக்கு, அதை எடுத்து பாருங்க, உங்களுக்கு புரியும் ஈஸியா. ஓகே, அண்ட் ஒன் மோர் திங், ஈக்குவேஷனை ரீரைட்டன் பண்றோம். ஓகே ஓகே, இந்த ஈக்குவேஷன்ஸ்லாம் இருந்தாலே போதும், நம்ம ஃப்ரீக்வன்சி ஆஃப் 2 ரோட்டரை சால்வ் பண்ணலாம். நெக்ஸ்ட் we move on to an 3 rotor system. Frequency of 3 rotor system, this is called instead of a 2 rotor there's one more rotor will be in a position. Okay, in somewhere in the middle of that. Okay, that is called 3 rotor system. A, B and C is a rotor name, and L1 and L2 L3 will be given for a 3 rotor system. Yeah, for this the node position is totally different. Okay, this is called a rotor system and this is called a node position of the system. Look at the cursor here, and this is called a node position of the system. Okay, this is called rotor A and this is called rotor B somewhere in this area, and this is called rotor C. Okay, same as like that. போடும்போது உங்களுக்கு LA L1 minus LA என்ற டேட்டா வரும். L2 minus LC and LC value. Okay, and this is called an rotor system, and this is called a node position of the system. Okay, you want to find out this A1 value, A2 value and A3 value, and this all values LA and L1 minus LA values, L2 minus LC values and LC values. You are finding out the node positions, you are finding out the frequency of the system, all those things. What is the need of this first of all? Okay, this எதுக்காக இதை கண்டுபிடிக்கும் அப்படின்னு பார்த்தோம்னா this will be taken into account for a designing. Okay, designing of a shaft, how the balancing it will be happen, how the force will be distributed, how the mass will be transferred from one point, how the energy will be transferred, how the mass will be shifted. Okay, like that all those things will be taken into consideration for a designing of a shaft and rotor systems. Okay, for that the frequency are very much important. Okay, vibration. And this and notations will be used there. L1, L2, distance from rotor A to B, and L2 equal to distance from rotor B to C, and LA equal to node 1 ல இருந்து A வரைக்கும் இருக்கிறது, LC ன்றது node 2 ல இருந்து C வரைக்கும் இருக்கிறது, and the mass amount of inertia for AB and C that will be given in IA and IB and IC, and D equal to diameter of the shaft, J equal to polar modulus, C equal to modulus of rigidity of the shaft material. Okay, this is Fn A equal to 1 by 2 pi square root of C by J LA into IA. And these are the formulas for a 3 rotor system. Okay, Fn B. Okay, Fn B equal to 1 by 2 pi C into J divided by IB, that is into 1 by L1 minus LT plus 1 by L2 minus of LC. Okay, and FNC equal to here. So since the frequency of A, B and C all are same, FNA equal to FNB, that is equal to FNC. Okay, put together we get the value of LA equal to LC into IC divided by IA. Okay, are equating 2 and 3, both the things here. So then one more formula it will be get it for you. And this is called a node position diagrams. Okay, this is called single node diagram. What we've seen in the previous diagram, that is called a 2 node system, and this is called a single node system. Here, look it out here, only one node will be there. Okay, and this is also one node. Okay, what we've seen in this diagram, this is called 2 node system. Node 1 and node 2 it will be there. You want to solve both the things also means you want to solve, okay, in a single node or as well as in a double node system, 2 node system. And this is called 2 node system. What we see now is called on a single node system. Only one node it will be pushed like this or this. It will be various based on the datas. Yeah, one more topic, that is called torsionally equivalent shaft. I think it almost introduction part is over. Just go through the slides. I kept on from first slide. Yeah, sorry, this derivation only, you know, you need it. Yeah, go through the slides. I move on to the next slide now. Just go through the slides. We go for the next topic in next classes, because so much of stuff in our One classes is not good. Please go through. Don't sit as ideal there. Suresh sir.
Yes sir.
Sir, in the PowerPoint presentation, the dataஸ்லாம் அனுப்பிச்சாச்சுல சார் நோட்ஸ்லாம்?
ஆமாங்க சார். இப்போ நேற்று பசங்க கேட்டிருந்தாங்க இல்லைங்களா, அந்த 23 சாப்டர் 24 சாப்டர் அது எல்லாமே வந்து நம்ம கூகுள் கிளாஸ் ரூம்ல அப்லோட் பண்ணியாச்சுங்க சார். அதுக்கப்புறம் வந்து பவர் பாயிண்ட் ப்ரெசன்டேஷன் அப்லோட் பண்ணியாச்சு. நேற்று பசங்க என்னென்ன கேட்டாங்களோ அந்த டீட்டெயில் எல்லாமே வந்து கூகுள் கிளாஸ் ரூம்ல அப்லோட் பண்ணியாச்சு. அலாங் வித் தட் அசைன்மெண்ட் கொஸ்டின்ஸும் வந்து ஒரு யூனிட்டுக்கு வந்து ஜஸ்ட் 2 கொஸ்டின்ஸ் தான் சார் நம்ம கொடுத்துருக்கோம். அதனால ஸ்டூடெண்ட்ஸ் வந்து பெருசா ஒரு டிஃபிகல்ட்டி ஃபேஸ் பண்ண மாட்டாங்க. 2 கொஸ்டின் வந்து நம்ம ஆஸ் யூஷுவல் அவங்க எப்படி நார்மலா எழுதி சப்மிட் பண்ணுவாங்களோ அதே மாதிரி எழுதி ஸ்கேன் பண்ணி கூகுள் கிளாஸ் ரூம்ல அவங்க அதை வந்து அப்லோட் பண்ணிட்டாங்க அப்படின்னா பேஸ்ட் ஆன் தட் தே வில் பி கிவன் மார்க்ஸ் சார். நம்ம அசைன்மெண்ட்டுக்காக வந்து நம்ம போட்டுட்டோம் சார். எல்லாமே அவங்க நேற்று என்னென்ன ரெக்வஸ்ட் பண்ணாங்களோ, சூர்யா என்னென்ன நேற்று ரெக்வஸ்ட் பண்ணாரோ அது எல்லாமே போஸ்ட் பண்ணியாச்சுங்க சார் கூகுள் கிளாஸ் ரூம்ல. அவைலபிள் சார்.
சாட் பாக்ஸ்ல கேட்டுட்டு இருக்காங்க, அதனால தான் கேக்குறேன் சார். விமல் குமார் என்ற ஒரு சாட் பாக்ஸ்ல கேட்டிருக்காங்க, அதனால தான் கேட்டேன். விமல் குமார் அப்லோட் பண்ணிருக்கு பார்த்துக்கோமா ஒரு வாட்டி.
ஆமா.
All those things will be uploaded in a Google Classroom.
விமல் அப்லோட் பண்ணிருக்கீங்க விமல் குமார். நீங்க கொஞ்சம் கூகுள் கிளாஸ் ரூம்ல கொஞ்சம் ஓபன் பண்ணி பாத்துக்கோங்க.
Just go through the slide, man. Don't keep as an ideal there.
லிசன் கைஸ், நான் சார் சொன்ன மாதிரி, பரணிக்குமார் சார் சொன்ன மாதிரி நாளைக்கு வந்து பாத்தீங்கன்னா உங்களுக்கு டிஓஎம் கிளாஸ் இருக்கு நாளைக்கு. அந்த ஃபெயிலியர்ஸ் அண்ட் ஆப்சென்டீஸ், அந்த எம்சிக்யூ டெஸ்ட்ல யார் யார் ஃபெயிலியர்ஸ் அண்ட் ஆப்சென்டீஸ் கேண்டிடேட்ஸோ அவங்களுக்கு எல்லாருக்கும் நாளைக்கு வந்து ஒரு கிளாஸ், ஸ்பெஷல் கிளாஸ் ஒன்று அலாட் பண்ணியிருக்கு. டைமிங் வந்து பாத்தீங்கன்னா 12:30 to 1:15. அந்த லிஸ்ட் ஆஃப் ஸ்டூடெண்ட்ஸ் நேம் எல்லாமே வந்து பரணிக்குமார் சார் நானும் எங்களுடைய அந்த ரெஸ்பெக்டிவ் குரூப்ல நாங்க போட்டிருக்கோம். இப்போதான் ஒரு 15 மினிட்ஸ் ஆகுது உங்க அந்த மெக்கானிக்கல் ஏ செக்ஷன் குரூப்ல போட்டு. அது எல்லாத்தையும் கொஞ்சம் பார்த்துக்கோங்க. நாளைக்கு வந்து 12:30 அந்த ஸ்பெஷல் கிளாஸ் வந்து அட்டென்ட் பண்ற மாதிரி பார்த்துக்கோங்கம்மா. ஆல்ரெடி உங்களுக்கு இன்ஃபார்ம் பண்ண மாதிரி இந்த 4 போர்ட்ஃபோலியோ தான் உங்களுக்கு வந்து மேஜர் ஃபேக்டர். எம்சிக்யூ டெஸ்ட், அட்டெண்டன்ஸ், அசைன்மெண்ட், அதுக்கப்புறம் ஃபாலோயிங் விச் ஒரு இன்டர்னல் அசஸ்மெண்ட் டெஸ்ட் ஒன்று கண்டக்ட் பண்ணுவோமா. இந்த 4 பேஸ் பண்ணி தான் உங்களுக்கு எல்லா மார்க்குமே வந்து உங்களுக்கு கொடுக்குற மாதிரி இருக்கு. சரிங்களா? அதனால கொஞ்சம் அதை ரைட்டா நீங்க கொஞ்சம் ஃபாலோ பண்ணிக்கோங்க. இது பாய்காட் பண்ணீங்க அப்படின்னா உங்களுக்கு வந்து சாரி டு சே தட் உங்களுக்கு மார்க்ஸ் வர்றது கொஞ்சம் டிஃபிகல்ட்டா இருக்கும். ஏன்னா தென் அண்ட் தேர் இந்த மார்க்ஸ் எல்லாமே வந்து நாங்க யூனிஃபைடு போர்ட்டல்ல அப்லோட் பண்ணிட்டோம். அப்போ நாங்க எதுலையுமே இதுல இன்டர்ஃபியரே ஆக முடியாது. எல்லாமே சென்ட்ரலைஸ்டு சிஸ்டமே எல்லாமே உங்க மார்க்ஸ் கிரேட்ஸ் எல்லாத்தையும் அவாய்ட் பண்ணி கொடுத்துரும். அதனால கொஞ்சம் அந்த நாங்க சொல்றத டைம் டு டைம் என்னென்ன சொல்றோமோ அது எல்லாத்தையும் கரெக்டா வந்து நீங்க கொஞ்சம் ஃபாலோ பண்ணிக்கோங்க ராஜா. சரிங்களா?
சரி, இப்போ இது வரைக்கும் இன்டர்னல் மார்க் நம்ம போட்டது எல்லாமே பாத்தீங்கன்னா கொஞ்சம் ஒரு பிளஸ் ஆர் மைனஸ் உங்களுக்கு வச்சுதான் நாங்க போட்டிருப்போம். ஓகே, ஆஸ் எ ஸ்டாஃப் மெம்பர்ஸ் ஓகே டே டு டே நம்ம பார்த்துட்டு இருக்கோம் அப்படின்றதுனால கொஞ்சம் பிளஸ் ஆர் மைனஸ்ல இருக்கும். ஓகே, இல்ல இந்த பையன் படிச்சோம் அப்படின்ற மாதிரி போட்டுட்டு இருப்போம். ஃபார் எக்ஸாம்பிள் இப்போ MCQ பாத்தீங்கன்னா எத்தனை பேர் என்ன அட்டன் பண்ணீங்களோ அதுக்கான ஆன்சர்ஸ் தான் வந்திருக்கு. ஓகே, ஸோ இதுல வந்து நாங்க மார்க் எதுவுமே நாங்க பிளஸ் ஆர் மைனஸ் எதுவுமே பண்ண முடியாது. உங்களுக்கு நீ பாஸ் ஆஃப் ஃபெயிலான்றது நீ உன் கையில தான் இருக்கு இனிமேல். ஓகே, ஸோ அது அப்போ அதுக்கேற்ற மாதிரி தான் இப்போ உங்களுக்கு என்ன வந்திருக்கு, இப்போ இந்த ஸ்பெஷல் கிளாஸ்ல உங்களோட நேம்ஸ் வந்திருக்கு. நிறைய பேர் பாத்தீங்கன்னா மோர் தென் 15 to 16 ஸ்டூடெண்ட்ஸ் ஐ திங்க் ஸோ ஆல் ஆர் 47 மார்க்ஸ். ஓகே, 47ன்றது என்ன, இன்னும் ஒரு கொஸ்டின் எக்ஸ்ட்ரா அட்டென்ட் பண்ணியிருந்தா நம்ம பாஸ் பண்ணிருப்போம். இதுவே கிளாஸ் டெஸ்ட் நம்ம கிளாஸ்ல என்ன பண்ணிருப்போம், சார் ரவுண்ட் பண்ணிருப்போம், 47 48 எடுத்திருக்கோம் அப்படின்னா ரவுண்ட் பண்ணிருப்போம். ஸோ நீ பாஸ் கேட்டகரியில வந்துட்டு இருப்ப. ஓகேவா? பட் இந்த சிஸ்டமே ஜென்ரேட் பண்றதுனால என்னன்னா நாங்க எதுவுமே பண்ண முடியாது. இல்ல 47 எக்ஸாக்ட்லி 47 மார்க்ஸ். புரியுதா? நாங்க எதுவுமே பண்ண முடியாது. ஸோ அதனால கொஞ்சம் இன்னும் நல்லா பண்ணுங்க. நல்லா பண்ணீங்கன்னா நல்ல மார்க்ஸ் உங்களுக்கு அவார்ட் ஆகும். ஓவராலும் உங்களுக்கு மார்க்ஸ் இம்ப்ரூவ் ஆகிறதுக்கு சான்சஸ் வில் பி தேர் ஃபார் யூ. ஓகேவா? அதான் சாரும் சொல்லிட்டு இருக்காரு.